Hello. Admitting all. Good morning, Eileen. All right, let's see. Pin this.
Good morning.
Hi. And hi, Junior. Totally joke, no problem. I hope. Anyway, a couple warm-ups there, folks, and folks are getting here. Whoa, one of those mornings. Excuse me. Oh, more. Here we go. You have to get out of the way so that I don't cast shadows here. Tough lighting. Come on, there we go. Welcome, Derek. And so, still waiting for a couple more coming and waiting for them to get loaded there. We're joining. And then everybody.
Good morning.
Hi. I put up a couple warm-ups, multiplication and division. Somebody had a question about anything they wanted to ask. Might be a good time if you wanted to ask me. We could use it to get started later, but let me know. Gonna wait and give you some time to work these out. I really encourage you to try to cancel, as much as you can before trying to multiply. Trying to make it work out. I put lots of stuff to cancel in there. Similarly, once you do what you need to do with the division problem. Oh, yeah. Well, if it keeps staying sunny, I might have to go outside and work today. Cleaning up some garbage from a construction project we did this past season. There we go, somebody else here. That's Charlie. And yeah, really just hanging out, giving you the time to try these on your own. Let's see, just thinking about notes you guys sent. Not a problem, but for anybody really, note that you do still have a hand-in homework assignment that's usually due on Monday, and I made it Tuesday because of the holiday, but because it had a fraction, basically the last problem on the first week hand-in homework is a fraction multiplication problem. There's a hint. So I bumped it until Thursday. So if you haven't gotten that done, please get it in. I'll start grading those soon and get rid of those zeros. I know you hate seeing in your grade book. I'll get those done soon. Yeah, it also occurred to me, oh yeah, you know, in the mom homework, now I double check to make sure that it was set up. There's all 1,000 settings I have to make sure I keep up to date week by week. But next to each homework question, you have the option of clicking the link to send me a message directly, or to actually use that problem to post a message in the forum. And if you do that, then I can see directly the problem that you are working on. And if you post it to the forum, then folks in the forum can actually see your version of the problem. I'm not sure I mentioned it. If you're not real familiar with mom, everybody gets a different version of all the problems, even on the tests, especially on the tests, you might say. Exactly same context, content and structure to the problems, but they'll use different numbers. So the idea is you got to do your own and not let somebody else do it. So your version will be slightly different than another classmate's. And so if you tell me, section 1.4, number 7 or whatever, if I really want to help you, I have to go look it up, see what your version is. And I can go in and look at everybody's individual work and attempts and what your versions look like. So I can use the numbers that you're looking at to help you. But anyway, that can be a useful link if you're trying to start a forum discussion in particular. Post this problem to the forum, and then see if you can get to help each other. All right, just a couple thoughts there. Let's see what else is going on this week now. Yeah, we're going to finish up 1.6, and we'll get to 1.8 and 9 this week. Not too tough. And so those will be due on Monday. And because it's kind of late, I did bump next week's hand-in homework that's due on usually Monday. I think I moved that to Wednesday also. Anyway, just check that calendar in Mom. Keep track of when things are due. Okay, I'm going to get going here. Anybody want to get me started? Brave soul, and tell me what to cancel here. Anybody want to pipe in? And
the 5 and the 35.
5 and the 35. Okay, yeah, that's the one that jumps out at me. It's like anything divisible by 5. Yes, I can divide this by 5 and that by 5, even though it's a cross. I did that on purpose, kind of, right? So, you can go all the way over here. If I divide both those by 5, that's what I have left. How about something else?
I did the 18 and 28.
The 18.
Say that one more time, please.
6 and the 18.
The 6 and the 18. There you go. Good. All right. They both are divisible by 6. Divide that by 6 makes that a 1 and makes that a 3. All right. Anything else we can cancel?
8 and 28.
An 8 out of the 28. Let's see. Both divisible by 2, huh? So that leaves that a 4, and that leaves that a 14. 20. All right. I see one more, right? How about the 7s? All right. Oh, and let's let this person in. There we go. 7s here, even in the 28, right? Could divide them by 7. So if I divide those by 7, I get down to that. So and again, so that means I'm already I've reduced it all the way down to this. If I cancel everything that we've noticed there. So that is 2 over, whoop, there's one more, isn't there? Look at that, see? All right, Steve, good. 1/6. There you go, I missed one, there's so much in there, right? That happens. And let's try this again. Let's get Kayleen in here, all right. Any questions or issues with that one? Now, just like I did, I guess, if you didn't see all those different things to cancel to begin with, you ended up with bigger numbers here, and maybe you would notice them at this step, like I did, or at least when you multiplied, look at your final answer and make sure there still isn't some common factor that you could cancel from numerator and denominator. Okay, all right, the other one, a division problem. What do I have to do?
Flip the reciprocal.
All right, which one?
The second one, you flip
There you
it.
go. It's always one. Thank you. Making somebody chime in and participate, right? So turn it into a multiplication problem, right? By multiplying by the reciprocal or inverse of the second fraction or the fraction that comes after the division symbol. We never divide. I'm stumbling today. We never divide directly. We multiply by the reciprocal. Okay. Now it's one of these things. Anybody recognize any common factors to cancel here? I sure hope so, because those are going to be big numbers. I didn't make it quite as obvious this time. Or easy, you might say.
26 and 39.
All right, what can I divide them by?
13.
There you go. All right, so you might say, oh, that's even, but nothing down here is even. I tried the 3s, 6, 7, 8, 9, 10, 11, 12. Oh, this is divisible by 3. All right, 3 times 13. All right, this is 3 times 13. Oh, 26 is 2 times 13. So maybe you had to go through all that work to maybe see it. But if I divide them both by 13, this one leaves the 3 and that one leaves the 2. Yeah, purposely thrown in some unusual numbers there, okay? How about those other two? Again, this one's odd and this one's even, so 2s aren't gonna work. The next one I usually check is 3s. 4, 5, 6, 7, 3s aren't gonna work. 5, 6, oh, well now 3s work here. What is this? 3 times what?
3 times 17.
There you go. So this, 3 times 17. Is that not all familiar over here? This is 2 times 17. All right. So I could cancel the 17s. That leaves the 2 over 3 and, oh, another 2 over 3. So I admit, I made that up with 13s and 17s, just so you don't completely get stuck on 2s and 3s and 5s or something, okay? Just think about it. And what, 4 9s? Nothing to cancel there. Okay. Hope that went okay for you. Well, I'm gonna pick up with our add and subtract. All right, where we left off yesterday, we were adding, basically, adding and subtracting. If we have the same denominators, we can just combine the numerators. I'll just do something real quick, like that. Those two fractions are the same, are built out of the same size pieces, same denominators. So we're going to come up with some quantity of 12ths after we're done with this. 7 of them minus 5 of them means I have 2 12ths. Now, it just happens that now that I've done that, oh, that one is not in those terms. I'll divide them both by 2s and get to 1/6. All right, that's the, don't we wish they were all like that kind of problem where they had the same denominator. So then we start doing a little more work. All right. So our challenge here is to come up with preferably the lowest common denominator. What number is the smallest multiple that they both go into? All right, and there's a couple techniques. 12 is 4 times 3, but that's 2 times 2 times 3. And 15 is 3 times 5. So I line up the 3's, but I need a 5. So the least common multiple or denominator's got to have 2, 2, 3, and 5 in it. It's got to have, it's hard to say it easily, the largest number of each prime factor that is in either number. I needed 2 2's to get a 12. I only need 1 3 to get both a 12 or a 15. And I needed 1 5 to get a 15. And so I could multiply those all out. The other way to do it is 1 times 12, 2 times 12, 3 times 12, 4 times 12, 5 times 12. I know where I'm going here. So 15's, there it is, 60. 60 is going to be our common denominator. I'll slow down. I'll stop. But those are the two basic techniques for coming up with the least common multiple, or the smallest number we can use as the common denominator. Yes, 15 times 12, I could get 180, but that's going to be big and messy. So I'm going to build two fractions. All right. I'm doing it, I guess. I'm going to make you do the next one. Build two fractions with 60 on the bottom, all right? What did I have to do to 12 to turn it into 60? How many times 12, right? 1, 2, 3, 4, 5 times the 12. So 5 and 5. Always, this really means I'm multiplying by 1. 5 over 5, I'm multiplying by 1, so I'm not changing its value. So I have to do the same thing top and bottom. What is that? 35. How many 15s? 1, 2, 3, 4. I had to multiply by 4 to get to 60. 44. Now they're all the same small size little pieces. How many 60ths? 79. More than one, improper fraction, fine. Leave it alone as long as it's reduced. Let's see, 9 plus 7 is 16. That's not a multiple of 3. I think we're done with that. Okay. So getting that common denominator is the challenge. All right. Here comes another one for you. All right. Here we go. Sorry. You always catch me before I erase. You need a copy. Just watch and make sure everybody's here wants to be here. And let's see. How about That's my, okay. I just warned you, I think our common denominator will be a kind of big number. You might have to do that multiple list kind of long if you're doing it that way. Or, if you want to use the prime factor method. So take a couple minutes right now and see if you can figure out what's the lowest common denominator. Oh, good. It started recording automatically. I don't remember pushing that button, but that's good. Right below my news. Folks usually remember, I can always do 15 times 24, but that'd be a huge number. I mean, we really like to avoid the number that big as our denominator. It makes the problems messier if we can. So we're looking for a smaller, preferably the lowest common denominator. I won't do too much, but you're doing it this way. All right. There's 15. Can you break the 24 down into its prime factors? Otherwise, you kind of got to keep your multiples list. I think is quite a few multiples before you run into the same one. How about if somebody gets it, they let us know. They get a good number they like.
120.
120, huh? Okay. So I was doing 24, 3 times 8. 8 is 2 times 2 times 2. I need a 3, I need a 5, and I need all those, so I'm going to call it 8 again, okay? 8 times 15. Yeah, get to the 120. All right, so there's that method. Yeah, 15, 1, 2, 3, 4, 5, 6, 7, 8. See how far down that list we had to go to get to 120 and 24, 2 of them, 3 of them, 72, 4 of them, 5 of them finally, right? Oh, there's the 120. That's kind of a hard one, I guess you could say. Had to work hard to find a common denominator. Process okay. Let me know if something's not making sense. All right, next step, build your next 2 fractions. I'm going to stop again. Figure out what to put on top. How many 15s did it take to get to 120? That's nice. You can just count down the list, right? 1, 2, 3, 4, 5, 6, 8. 8, right?
Yeah, 7 times 8.
Got to do that to get to 120.
Right.
And 24s, 1, 2, 3, 4, 5. Kind of like half of 24 is 12, right? 25. I like to throw out the little like mental math tricks sometimes. So that's what we're trying. That's what you need to do. Next step, 7 times 8.
56.
56, right? When I was a kid in school, there was 7 times 8 and 6 times 9. Which one's which? 56, 54. I had to remember 5, 6, 7, 8. 56 is 7 times 8. I had to find a trick to keep those 2 straight. But anyway, all right, what is that?
95.
95, all right. So 56 minus 95.
Negative 39.
39. Can we take his word for it? Everybody okay with that? Now they are opposite signs, so we find their difference. All right, we still kind of do subtraction, find their difference, big one minus small one. Got to do the borrowing thing, right? And I got a 39, but the negative was the bigger number, so it is a negative. Negative 39. Am I done?
No.
That's my loaded question whenever I say that. Am I finished? 3s, right? Just 9, 10, 11, 12. I can divide that by 3. So I divide that by 3. I saw that number not too long ago. Negative 13. If I divide that by 3, it's a what, 40? So negative 13/40ths. Final answer. 13's prime number, you know you're done there unless this is divisible by 13. All right, that's kind of messy, right? Do it again here, okay? Somebody's tried these in homework and got stuck, you know, you could throw out a question. It's supposed to be a 7. back it up a little, not so crazy. But I threw a variable in there. Uh-oh, what does that mean? Find your common denominator. You might not have to work too hard on this one. You might just be able to say, oh, I know what it is. Because they're small numbers. Maybe you could do it that way. What am I going to use here? What do you
18.
like? I think I heard it. 18, right? 18 works pretty nicely. Not too much work for both of those. All right, so how do you get to 18 for each of those denominators? I'm going to assume you're pretty comfortable with this. 3 times x is just 3x. This is a little different. So then that's a 14, right? Now we're ready to add. Notice here, I mean, oh, there's an improper, there's a fraction I could simplify. Well, no, we just did that on purpose. We made it 18 and 14, right? Don't try and go back to ninths again, then we don't have common denominator, right? So I have 18ths, but those are not like terms, right? I have some x's, whatever that represents, and a 14, and I'm done with that, just like that. Let's see, I'm thinking about mom and how you might present an answer like this in mom. I think, now there's the answer box. Put the equal outside or something like that, you know, don't try to say equals. But I think what you want to do is click on that tab underneath that gives you lots of choices for the format. And there's one that kind of looks like box over box, fraction bar, right? I think you're going to want to use that for this kind so that, oh, click on this, and then it knows that you're writing a fraction with those 2 pieces on top and the 1 piece on the bottom, all right?
You could also do 3x plus 14 and then backslash 18, and it'll do that format.
Okay, so that, thank you, whoever that was, but, oh, I gotta let somebody, I thought maybe Kayleen was in, but maybe she had to leave. That's really kind of why I'm addressing this. If I do just this, now, I don't think mom's ready to fix it for you. This is not entirely correct. This is not really correct. This is a separate term, 3x, and kind of like order of operations rules. It's only 14 that's getting divided by 18. The 3x is not in the denominator when you write it horizontally like this, unless you group it. So we're working with a newer version of mom this year. In years past, it didn't always present you this option, and you had to be real careful that if you had multiple terms in your numerator, you had to group them yourself before you use the slash. Now, whoever suggested that just a minute ago, if you actually tried it that way and it's worked, that sort of confuses me, but this is safe. This is the safer thing to do. Hope that makes sense. The difference I'm making there, right? Without the parentheses, it's only the 14 that gets interpreted as divided by the 18. Okay. All right. Good. All right. And all right. Let's see. How about some messy ones? Complex, huh? Here we are looking at a fraction with fractions inside of it. Remember, this is what we called complex fractions. That's sort of the definition of a complex fraction, is one that has fractions inside of it someplace. The fraction bar is a grouping symbol. Do the top first, do the bottom separately. simplify each part separately before trying to combine or cancel after that. So what's 1/3 times 1/3? Right? Yeah, that's all that's saying is 1/3 times 1/3 is 1/9. Square the top, square the bottom. All right. 2 cubed. 2 times 2 times 2, right. Not 2 times 3, but 2 times 2 times 2, 8. All right. So I get to 1/9 over 12.
Isn't that just 9 over 12?
Nope.
No?
I mean, does this make sense so far?
Yeah, that makes sense, yeah.
1/3 is 1/9, and this is over 12. So the numerator is still this fraction. And whether you do it or not, I can sort of think about that one as a fraction. Remember, so what this represents now is I'm dividing this fraction by this whole number, which 1/9 divided by 12. Remember when we talked about these yesterday? This is fraction divided by something. We're going to turn that into multiplication. Lots of little things happening right there in that problem, huh? Okay, so that was just a 12, even if I didn't put the 1 on it yet, right? I'm going to divide this by 12. I'm going to multiply by the reciprocal of 12. And that's where you want to imagine that it's this fraction that you can flip over and make it 1/12. I think that's 108.
Yes.
All right, so that's what you want to get to with that. I got another one. 2 more of this kind, you might say. Okay, I'm going to erase. Ready, set, go. All right. How about playing with those exponents? Grouping symbol bar here. Simplify the numerator, simplify the denominator, and then look and see what we have to do. 4 squared, 16, 1 plus. Okay, what's the denominator?
1/8.
See, that's why I asked. I'm sorry. This is 1/4 times 1/4.
1/16.
Yep.
Okay.
Excuse me. 1/16. My bad.
I hope, please don't be offended. We'll figure, we learn from it, right? Yeah. 1/16. All right, now I got fraction with a fraction in it. It's a division problem. 17 divided by 1/16. Okay, you want to be able to, oh yeah, totally makes sense. This means that. We don't divide by fractions, we turn it into multiply. Flip, invert, and multiply. 16 over 1 is just 16. All right, who's got a calculator? Do this if necessary, all right?
272.
272,
Yes.
and hopefully I'd get the same thing that way, right? Okay, 272, just a whole number. Nothing to simplify. All right, one more good messy one. Here we go. Shout out, wait, I erased too soon. This is like 4 problems in one or something. The top has two fractions I have to add and get a common denominator. The bottom has two fractions, kind of like subtracted and subtracted. I have to get a common denominator. Make that your first step. Maybe just rewrite it. Notice that you can do the top separate from the bottom. They don't all have to have the same common denominator. That's not necessary. What denominator am I going to use for a 2 and a 3? 2 times 3, a 6. All right. I would say make this your first step. Get two fractions with 6 on the bottom. Similarly, looking here. What do we use for 3 and 4? And I'm going to stop and let you do it. But I'm hoping you're thinking 12. Don't lose your negative sign. Put those both under 12s. I'll let you fill in the blanks now. You can get the same denominator. It doesn't often, save you anything by trying to make them all the same. What am I doing time-wise here? Good. Hey, Kayleen, I had to let you in again. Maybe you fell out or something, but I hope that worked.
We're having technical issues at work, so yeah, sorry about that.
Good, glad I caught you there. Noticed.
Yeah.
Yeah. All right, so here I'm going to go 2 over 2 and 3 over 3 and get 2 plus 3. To get to 12s here, I'm going to squeeze it in. 3 over 3 and 4 over 4. So this one's negative 9. And that one's just 4. Let me know if something didn't make sense there. Now, still working within numerator separately from denominator, you can combine them, right? How many sixths? 2 plus 3, we call it 5 sixths. Now this is the way I like to say it, negative and then more negative. We're going left and farther left. Negative 9 minus 4 more. Negative 13 over 12. Finally, we can turn this division problem into a multiplication problem here. It is positive divided by negative. Don't lose those. 5 sixths divided by, there's my extra parentheses for the negative sign. All right. So now invert and multiply. Turn that second one over. Here I can see it on my screen. That's a division symbol, not subtract. My dots don't always come through strong enough. 5 sixths times, flip it over, negative 12 13ths. How about canceling a bit? See the 6s? I'm kind of crooked here, but 1 6, 2 6. Positive times negative. 2 times 5. 1 times 13. Whoop, 3.
Can we do another one of those fraction things?
I'm just gonna say, I bet you won't see them quite this messy, but should we do another one like this? Yeah, I'll do one. I'll make one up. Ooh, that's scary. All right, here we go. Folks, got enough of that? I'm gonna erase. Okay. So let's put it, I'm gonna make that minus minus again, just for fun. I don't know. And Let's not get too crazy. Okay. I just made it up, so I don't know how it's going to work out. Usually I have examples in my notes, so. Yeah, I see how one problem could put a whole lot of concepts in there. That's often dangerous. That's why we give you partial credit. One wrong turn, you get the whole thing wrong. But so then I have to work hard and check your work. Try not to do too many things in one problem. Most of the time. What's a good denominator for the numerator? What's the good denominator for up top?
20.
20. 20, okay. Don't want to get too far ahead of you. Anybody figure out a good one for the bottom? Not yet. Okay.
24.
I like it. Okay. You're on your own. Take a break. Which pieces are bigger, fourths or fifths?
Fourths.
Yeah, if I divide something into 4, those are a little bigger than if I divide it into 5s. In our next section, they're going to ask you to kind of put greater than, less than arrows in between fractions like that. Which one's bigger? Which one's far, on the number line, which way, Which one's bigger than the other? No common factors there. 4s, 5s. I hope that. I'll do that much for you. Figure out that next one. How many 8s? 3 times 8? How many 6s? 4 times 6? Some weird numbers. Open, you're ahead of me. I just like emphasizing the negative and more negative. I might say a larger absolute value, a larger negative, which is contradictory words really, but negative 27. And what's this? 43? I almost said 33. Easy to make that one, right? 43. Yeah, we'll get to do a little canceling, but not much on this one. Now, if you're all confused, I mean, I say this over and over yesterday, if you understand, you're just going to flip over this second one and make the bottom one and make it multiply. Any confusion, just rewrite it as a division problem, arithmetic-wise, you might say. I use the arithmetic symbol for dividing, right? There's the division version. Now we turn it into multiply, right? Flip it over.
I do have a question, sorry.
Okay, good.
So how did you get that negative 27 over 20?
Okay, we were up here, I got 12 and 15, right? So here was negative 12 minus 15 more. This is where I'm glad you're asking. This is where when I use that phrase minus and more minus, right? I'm at negative 12, and then I went 15 more negative, right? I went even more negative to get to negative 27. Negative 12, I subtracted 15 more. I went further left.
Okay.
Does that
Okay.
make sense?
Yes. Thank
Yeah,
you.
so that's this minus and then minus some more. And I use that phrase, minus and more, minus, you're getting, when I say a larger negative, you're getting a more negative number. Yeah, good. Yeah, you just, sometimes the picture, the visualization helps. I mentioned that in the forum problems, like start here, go down to here, draw yourself a picture. I like that with the thermometer questions. I made up one, oh, you started at 85 degrees and you went down to minus 20. What was the difference? If you do a graph like that, you can kind of see, oh, it's 85 plus 20, right? That's what that distance is. Totally side problem there. Here, I don't know where that came from. Negative 2720 times 24 over 43. Is that okay? Except for the messy numbers you made up, Steve. How about at least some evens here?
Yeah, can you read
By my
this?
fours. How about we get some
Right.
fours?
That's what I did.
Okay. Now I got to just multiply, all right? 6 times 27. I know you guys have calculators. 12, 16, 162. This is going to be negative. Don't lose this negative sign. And 5 times 43.
215.
215. Good for you. All right. And we did all the canceling that we could do at this point. I'm going to say that's lowest terms. It's really sad when you forget, you lose that negative sign. Try real hard not to lose track of your negatives. It's one of those I give you most of the credit, but I gotta ding you some if you lose your negative. All right, so there we did another one of those. Let's see how we doing. Couple minutes left. You know what? I was prepared to. We're done with 1.6. All right, we could do something else. Another one of these. One of these different, any kind of fraction probably you might want. We've got a couple minutes. I'm not going to try to start 1.8. 8 and 9 are kind of easy, I would say, or short. We'll do them together tomorrow. 1.8, 1.9. I'll mention a couple things about decimals. I brought it up yesterday. Also yesterday, just make sure you understand things you got to be able to do with decimal values. Add, subtract, multiply. So almost out of time, but anybody really want to suggest one more, or should we call it? You had
One
enough.
more if we can, please.
Pardon? One more.
I said one more, please.
Like that, the complex kinds?
I agree.
Okay, all right. So, I'm gonna look for some suggestions. Yeah, just gotta make them up. Okay. Could leave well enough alone. Have to mix it up even a little more. That's boring. Same denominators. Oops. I was just making it up. So notice my square up there, of course. That's what's different, right? 1/2 squared. Got to square that before you do anything else. Just to mess you up, right? One half times 1/2. What's half of a half?
1/4.
Thank you. All right. Honestly, I just made up these numbers. And what I just said, yeah, oh, isn't it the same denominators as the last problem? I think we're going to use 20 again and 8 and 12. Now, different way to get there, starting with different base numbers there. But yeah. You run out of time, you've got to go, you got to go. That's all right. It'd be okay if I just do this. All right, I'm okay with those two numbers, huh? Working over there to get there, all right? How about oh, that's interesting. Okay. Okay. 5 minus 12. -7. What's that denominator then? Minus or more minus?
-29.
There you go. All right. See how messy this turns into, huh? So there's our reduced fraction, I guess. So -7/20 divided by -29/24. Squeeze it in and I'll come back over here. Turn it into multiply. That's a division symbol, hard to read, sorry. 7/20 negative, whoops, Steve, don't know that. -24/29. All that just to get, finally we can do the little canceling again, right? Do some 4s again. Makes it a little better. Negative times negative. Now, not negative plus more negative, but negative times negative, the opposite of an opposite, can be positive. 6 times 7.
42.
Yeah,
42.
yeah. And 5 times 29.
145.
I heard your 4 by hand. 145, okay, good, thank you. 145, 5, 6, 7, 8, 9, 10. Yeah, we did as much canceling as we could. Oh, yeah, positive. Ta-da! We're done. And we're done for the day, okay? Really, now we've covered it, all the kinds of things you will run into in 1.5 or 1.6. And now I did make the due date next Monday, but get it out of the way if you can. next Thursday is our first chapter test. So we have sections 8 and 9. It's kind of like properties and rules. 1.10, that's a Monday, an important section where we do what we call unit conversions, change from feet to miles, or even meters to feet, metric to English units. And our Tuesday lesson is entitled Geometry. Really, it's a bunch of formulas, like here's the formula for the area of a circle. Plug in the numbers and see what you get. So we're not doing a whole lot of geometry. We're using the geometry formulas to play with our numbers here. Okay, so Monday and Tuesday, still things to work on. Wednesday next week is our scheduled review day. And then the test is bumped to Thursday next week. So can't let up yet, okay? I did read, some folks said, oh yeah, right now it's mostly like review from last term. If you were in Math 20 last term, yes, this first chapter should seem like a lot of review. Math 60, however, is the first or entry level class for a lot of folks. They test into Math 60, so we really have to cover all these foundations again. So we go over it, but then we move on. All right, send me your questions. I'm hanging around.
Do you have time to stick around? I have a couple more questions after.
I certainly do. I certainly do. Okay, so anybody wants to hang out, fine. And otherwise, I'll see you guys tomorrow. All right.
See you tomorrow.
Feel free to
day.
log off, and I'm gonna erase this one, whoever that was. Right? Was that Kayleen?
Sounds good.
Professor, I have a question as well after my classmate.
Yeah. I'm just going to the grocery store later. No problem.
Can we do another one of those problems again so I know I got it down?
You mean that?
Yeah.
Yeah. The complex fraction ones. Okay. All
Yeah.
right.
Can I just ask a real quick question? It was pertaining to the previous question that we had. You had, the question was 1/2 in parentheses with exponent of 2. So basically, you came up with 1/4 by just adding that. I know
It's one, unfortunately, one where 2 + 2 = 4. But the reason we got 4 is because it was 2 times 2.
Mm.
okay, that's what I was hoping.
Good question. Like if I did one like that, so this is 3 times 3, and you get 1 times.
So I just wanted to clarify that because I just wanted to remember the rules. Thank you.
Yeah. Yeah. Some of those numbers are unfortunate that way. You get the same number different ways. Yeah. Okay. All right. So how about?
Do one with exponents.
What?
Do one with exponents.
Oh, fine. Be that way.
Yeah.
That's not hard. Make us work. Oh.
You've doomed us all.
Sorry, not sorry. That's how we learn, right?
I missed that, folks.
Sink or swim. You got to do it eventually.
Yeah.
Just going to get bigger numbers eventually to work with. Yeah, like I said, this has got like 1, 2, 3, at least 4 of our major concepts in one problem from this chapter, just dealing with fractions: add, subtract, multiply, and divide, all in one problem. That would be too much for a test problem. I'll just give you that hint. We wouldn't try to mix this much into one test problem, I'm pretty sure. Well, I don't have to eat my words there, but all our classes use the same tests, all the Math 60s. Everybody's problems are different, but everybody sees the same type of question in all the Math 60s. So we're all consistent with what we're covering. Nobody gets shortchanged, huh? All right. I'm going to do my exponent. So what denominator do I have to use up there? Right? You got this one, right? So what works for those two? 3's and 3's, 2's and 2's. I just got to multiply and get 36.
36.
Yeah, there's no overlapping factors. This is built totally out of 3's, built totally out of 2's. The number that would work for both of them has to be the 36. Really similar for 5 and 6. No common factors, so I just have to do 5 times 6 to get that common denominator. This one's going to be 30. All right. I'll stop and let you go from there. Hopefully that made sense to you, though. Yucky numbers. 43. Six minus 25. 6 minus 25, we end up on the negative. 25 minus 6 is negative 19.
Can't you simplify the 16 and the 36 across?
Oh, not if it's addition. Only
Not
if,
addition?
not if it's addition. It has to be multiply, 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 and then you're canceling factors.
Got it. Cool.
Yeah, anytime it's plus minus, these are separate terms. You can't cancel. And really, we built the 36 on purpose so that we could combine those. You know, we don't want to change our denominator now. We just did all that work to get there. But these are kind of messy. Yeah, that's important. If it's not strictly multiplication in a row, numerator and denominator, you can't cancel. You know, I see things like something like that, and somebody might say, oh, I can cancel the 4's out here. No, that's just like an extra 4 hanging out there, and you can't do anything. They're separate terms. Those aren't factors. Not a bunch of multiplied things top and multiplied things on the bottom, and you can't really say you're dividing it by 1 or multiplying by 1. All right, getting technical there, but all right, okay at this point. Gonna flip that over. Really messy number. Don't lose your negative. Hopefully we can simplify something. Just 6's, huh? How about 6's? I can get 6 out of there, makes this 6, and that's a 5. Maybe you did 2's and maybe you did 3's, but those are 6's, right? 5 times 430 is 215. Six times 19, 54. 114. Yeah. See, 5, 6, 7, 8, 1, 5. Well, we found everything to cancel. If you cancel everything here, then if you're really confident you found all the common factors here, then you don't have to worry about the end one. That's why we do it. All right, that's enough of that, okay?
Thank you.
Yeah, we can do that tomorrow
Professor?
if you feel that's important enough. All right, anybody else? Some other kind of question you guys are hanging around?
I have a question, Professor.
Yes?
This is an earlier problem that you that we went over.
Yes.
The
Hope I did it right. Go ahead.
It was 7/15 minus 19/24.
Okay.
Okay. When we were going over the common denominators, this is a silly question. I'm sorry, but I just need to clarify this. We needed to find the common denominator for 15, right? So we're breaking down into prime factors. So for 15, it would be 3 times 5.
Yes.
Now for 24, I was thinking it was 8 times 3. So when I was doing my thing, I did well, the way you presented it was 3 times 2 times 2 times 2. So that 3 2s that you have there,
That's
I
the
don't. Do I?
8 breaks down into 2 times 4, which is 2 times 2. Really,
Right.
I almost said it when we did this one. Once you got to the point you realize 8 is a completely separate factor than anything up here, you know you're going to have to use that whole 8. Yeah, you could have left it an 8 because
Okay.
there were no 2s up here. If this had been like 30, right? 3 times 5 times 2, well, we really want to see that there is one of those 2s in common. So that's why we go all the way to all the prime factors. I'm cutting you off.
What I'm actually bringing down is 3, 5, and 8.
Yeah.
Right? Okay.
Right.
I just wanted to verbally hear you say that so it'll stuck in my head.
Yeah. So the 2, 2, 2, yeah, 3 of the same prime factor is 8. Yes. So there's
Okay.
2 times 40.
Thank you for clarifying that. I appreciate you. Have a great day.
Thank you. You too, Rodney. See ya. Anybody else? All right.
No, I just stuck around for the extra practice. Thank you very much.
Good to see you there, Gwen. All right. We'll see you tomorrow.
All right.
Thank
see
you.
tomorrow.
You're welcome.
Take care.
Take care.
Enjoy some sun if you can. Yeah.
Oh, yeah.